Hi, folks. So, your assignment for this week is to design a solar roof for your house. I thought it would be easier to step through it if I showed you in a video what exactly you need to do. And I'm going to start with the assignment that you did last week. Last week, you calculated how much energy the sun delivers to every square meter of Earth, measured in kilowatt hours per square meter per day. So, for example, in Massachusetts, using this graph, you would have determined that Massachusetts receives between 4.5 and 4.75 kilowatt hours per square meter per day. That's the sun energy that's shining directly down on the earth. And even though it's measured in kilowatt hours, which is a measure of energy, that's not the same as the amount of electrical energy that you can get from the sun. In fact, if you could turn all that sun energy into electricity, you would only need solar panels on your roof working for about 5 minutes a day, and then you would collect enough electricity to power your house for the rest of the day. So what we're really interested in is how much of that solar energy you can actually convert into electricity. And there are a couple of limiting factors that you need to consider. The first is the size of your roof. Obviously, the bigger your roof, the more solar panels you can fit. And the more solar panels you have, the more electricity you can generate. Another important factor is shading. If you have trees that are shading your roof, then you're not going to have as much solar energy shining down on your solar panels, and you're not going to get as much electricity out of them. And then there are three other factors that also matter, but they require a little bit more explanation. They are latitude, the tilt of your roof, and something called azimuth. So I'm going to walk through each of those one at a time and explain a little bit more what each of those means. So the latitude means how far north or south from the equator you are. If you're near the equator, the sun shines straight down on you. But further from the equator, the sun's rays are spread out over a wider area, and that means that the energy is more spread out. And we understand that already because if you've been anywhere near the equator or know anything about it, you know that that's a very hot part of the planet. That's because the sun is shining directly down onto that part of the earth. But the further away you get, the more spread out the sun's rays are. And at the extreme poles, at the north and south pole, it's the coldest because the sun's energy is spread out the most at those points. And you can compensate for the angle of the earth and the angle that the sun hits the earth by tilting your solar panels up to get direct sunlight shining down on them. And the closer you are to the equator, the less you need to tilt your solar panels up. The further you are from the equator, the more you need to tilt your solar panels. So notice that in the left-hand diagram, that might be a place like Hawaii, which is pretty close to the equator, and you would only need, for example, a 20-degree tilt of your solar panel up to meet the direct sunlight. But if you're a little bit further north, like where we are, for example, in Massachusetts, you would need to tilt your solar panels a little bit more to get the direct sunlight. And even though you can tilt your angles to get the direct sunlight, that sun's energy is still spread out a bit more. So you're not going to get quite as much solar energy from your solar panels at higher latitudes. So another thing that affects the angle of the sun on the earth is the time of year. And we can show that with this Google Earth demonstration that shows the earth spinning around, and it shows what parts of the earth are lighted by the sun during the winter and the spring. During the winter, you'll notice that the sun is shining more on the southern part of the earth, And in fact, the North Pole is dark most of the time of the year during the winter. During the spring, like this time of year right now, the Earth is tilted so that the sun is more directly overhead. And what that means actually is that during the winter, the sun is at a lower angle, and at the summer, in the summer, the sun is at a higher angle. So that also affects how much solar energy you can get at different times of year. So the last thing to take into account in terms of putting solar panels on your house is what direction is your house facing, and that's called the azimuth. Azimuth refers to the angle of your roof in terms of north, south, east, and west. We call north 0 degrees and south 180 degrees. And in the northern hemisphere, you get the most sunlight if your house is facing south. So you need to know what direction your house is facing so you can determine how much sun energy you're going to get. In my house, it's the right side of the roof that's got the solar panels on it. And if I indicate the direction that that's facing with the red arrow, and then I put that same arrow over on the compass on the right, then it lines up with an angle somewhere between 105 and 120 degrees. And actually, my roof's azimuth angle has been calculated to be 112 degrees. So that's not ideal, but we still get plenty of sunlight in spite of that. Okay, so putting this all together, all the factors that we just talked about, you are going to use something called pvwatts calculator to figure out exactly how much electric energy you can generate from solar panels on your roof, and also how much money you can save by doing that. So to get started, you will go to this website called pvwatts.nrel.gov. And once you go to that website, this is what you will see. The first thing that you're going to do is type in your address. And then hit go. And the reason you need to put in your address is because it needs to know your latitude in order to calculate the solar energy at your location. So you see that now that I put in my address, it shows the latitude and the longitude, called lat long. We happen to be at a latitude of 42 degrees north and a longitude of negative 70 degrees. So once you put in your latitude and longitude, the next thing you do is go to System Information. And there's a bunch of boxes that are already filled in for you, but you need to make a few modifications to this. The first thing that you need to do is tell pvwatts how big your actual roof size is. And you're going to do that by going over to this Draw Your System area. Click on that box. And then it's going to show the location of your house. You might need to drag it around a little bit to get your actual roof. But once you get your roof within the border of this window, then you need to tell it how much of the roof you're actually going to put your solar panels on. So in my case, it's only this side of my roof that I have solar panels on, not this side and not this garage over here. So if this is the area that I want to put solar panels on, then I just click on the four corners of it and it'll calculate the total area of that part of the roof. And I click Save. And then it goes back. Now it knows how much roof I have available to put solar panels on. And it uses that to calculate what the kilowatt capacity is for that many solar panels on your roof. So this number is now 13.7. That's how many kilowatts I can produce from the solar panels on that part of my roof. The next thing that you need to do is put in the azimuth of your house. So we talked about azimuth means the angle of your house relative to north, south, east, and west. And you're going to use a compass like I showed you earlier. In my case, we calculated the azimuth to be 112 degrees. Not ideal, but still plenty of sun shining on a roof at that angle. And the tilt, um, if you don't know what the tilt of your roof is, so that's the angle relative to horizontal. If you don't know what it is, then you can take a guess. I'm going to put in 40 degrees because that's about right. And that's almost equal to the latitude of where we live. So that would be a good match for the tilt of the solar angles. So now I've put in the area of my roof, I've put in the tilt, I put in the azimuth, and one other thing that you can put into this calculation is shading. So you put in shading by going to this button called Loss Calculator. If you click on that, there are a bunch of different things that are pretty sophisticated that you probably don't know much about. But notice that one of them is shading, the second one down. Let's say you know that your house is shaded a little bit of the year. Maybe 10% of your roof is shaded during the year. So if you put in 10% here and then save it, that means you're going to get that much less solar energy. And it just calculated the system loss as a percent from 14 to 20% because I told it I have a little bit of shading. So now you've done everything that you need to calculate your solar energy. So the next thing you're going to do is click on this orange arrow on the right that says go to pvwatts results, or you can click on results up here. And it's going to tell you how many kilowatt hours per year you can generate from solar panels on your roof. Because the sun's angle is different during different months of the year, you're going to calculate the most electric energy during the summer months. So notice here, for example, July, I generate a lot of electricity, but in December, not very much at all because the sun is so low in the sky. So the last step is for you to take a screenshot of your results and submit it. That's your homework for this week. So good luck, folks. If you have any questions, let me know. And otherwise, I will see you online.